Greetings and welcome. My name is Stephen Terrell, and for my presentation, I'll be discussing information technology and the 7 layers of the OSI model. The reason I chose this topic is to kind of explain in a little bit of detail the different layers of the OSI model and to share with some of my experience with working in the field as a network engineer and to hopefully give a little bit of a breakdown for people who may be struggling to understand what is happening behind the scenes at some of these layers. What exactly is the OSI model? The Open Systems Interconnection, or OSI, model is a 7-layer architecture, and this is how data is transmitted and received across the network. So going down the list, we have the application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. These are often referred to as the numbers as well, so layer 7, layer 6, layer 5, layer 4, layer 2, layer 1. And the following slides will be a little bit of detail into each of these, and so let's dive in. Why is the OSI model important? For me personally, and probably for some of you, the OSI model is important because things go awry in IT, and this can happen at layer 1 all the way up to layer 7. Some of the common issues that we see at layer 1 are things like people moving a cable, things that happen at layer 2 and layer 3 where your switches and routers reside. Sometimes things happen where power goes out and those devices will go offline, and so you'll actually lose layer 2 and layer 3 connectivity for X amount of time depending on what the issue is. But the OSI model itself is kind of a path to follow whenever we're looking at what the issue is and where the issue may lie. So just because there's a layer 1 issue, if we're looking at a layer 3 issue, which would be a routing issue, we wouldn't be able to make any progress because layer 1 is disconnected. That physical cable is disconnected. And in some of the following slides, we do have some examples, and I'll kind of go over some of that information as well. Layer 1 is physical connections. That could be anything from a power cable charging your phone or your tablet, or maybe it's a power cable that's powering on your monitor. And of course here in the slides I have some pictures of what looks like Cat6 Ethernet cables and some multi-mode fiber. And oftentimes these connections are disconnected, moved, maybe a cable goes bad, and that happens more frequently than probably a lot of people like to admit. And so people like myself, or maybe even a third-party technician, depending on where some of the equipment is located, will have to go to a data center or go on site to help an end user and either re-tip one of the cables if it's an Ethernet cable, or fiber cable is very sensitive because it transmits light with inside those tiny little cables. And if they get bent or crimped the wrong way, then it actually breaks some of the stuff that's inside, and so that cable will have to be replaced completely. I'm sure that some people have had similar experiences with their power cables for their iPhones or some Samsung devices as well. But this is usually where we want to start whenever we're beginning to troubleshoot an issue. It seems a little bit silly to ask somebody if something is plugged in, but sometimes that is the case and a cable just needs to be moved or reconnected. Since layer 1 includes any sort of physical connection, this could be any sort of external device as well. So if you went to work and brought a USB from home and connected that to your laptop, to your work laptop, that may be an issue. That may be a problem or a big no-no that is definitely frowned upon. And that's not to say that you're coming in with malicious intent or trying to steal company data, but just oftentimes it's better to not allow any sort of connectivity like that from USBs or external hard drives, and that way there aren't any issues or any sort of viruses or malware that gets put onto a company network just because you brought a device from home that you assume is safe. Even though you're doing a virus scan or a virus check on some of these devices, it's still frowned upon to bring them into work. Looking at layer 2, the data link layer is where a lot of devices like PCs, laptops, phones, cameras, wireless access points get connected into switches that provide internet connectivity by configuration of VLANs and spanning tree. And so this is where we look at a lot of MAC addresses for the hardware that is connected, and that way we can tell what port it's connected on, if that port has PoE or power over Ethernet and is pulling the proper power that it needs to. Sometimes when fiber connections are connected into switches, they are connected into what is known as a GBIC or SFP, which is an adapter that essentially goes into an Ethernet port that we see here, and it allows the fiber connection to connect to that port as well. Sometimes some of these ports are configured logically on the switch itself to act as one connection, and the reason that you would do that is to increase the bandwidth between wherever, whatever devices are connected to the switch. Typically we have servers that are configured for link aggregation so that computer backups can run, or maybe there's a application or web server that needs to have high throughput for multiple people in the office accessing that server. One thing I would like to mention is that another layer 2 device is a hub, and hubs are pretty outdated these days, mostly because they operate at half duplex instead of full duplex, which means that they can only send or receive at one time instead of sending and receiving at the same time. And so sometimes we'll find hubs in older environments or legacy environments, and whenever possible, those devices need to be replaced. So one of the tools that we use at layer 2 to determine connectivity is by looking at the MAC address. And here you can see a couple of different formats that MAC addresses are typically presented in. And the protocols that are used, if you're on a Cisco device, they have what's called Cisco Discovery Protocol, or CDP, and a lot of other devices have link layer data protocol enabled, or LLDP. And so what we would do is use something like a show command and say it would be show CDP neighbors, and it would show all the MAC addresses and any devices that are connected to that switch. And that way we can see the layer 2 information here, and we would also use these MAC addresses to create IP address reservations and tie it to this physical MAC address so that no other device can obtain that IP address. So this is layer 3, and definitely where things start to get a lot more complicated. Layer 3 typically includes routers, and a lot of times these days firewalls as well, because these devices use different routing protocols to send IP packets across the network. And of course there's IPv4 and IPv6 addresses. I won't get into those too much. That's a bit outside of the scope of this, but I definitely did want to mention it. I'm sure that most of you are aware of what an IPv4 address is, and usually it has a subnet mask that is tied to that, and also a default gateway so it knows where to send that IP traffic to. Here I have just an example of an IPv4 address, and below the IP address you can see some of the 8-bit binary numbers that correlate with what the actual values are within the IP address itself. I did not include an IPv6 address just so that things remain as simple as possible. At layer 3, using this IP address and other IP information, some of the troubleshooting and tools that we would use is ping and traceroute. Using ping will show us if we have reachability to some of the IP addresses. So if I was a user who was logged onto my work computer and had the IP address of 172.16.254.1, I would be able to pull up command prompt and type ping.8.8.8.8, which is to Google, and there would usually be a package of 4 packets that are sent, and it would tell me if there's any sort of packet loss there. This would help determine how the network is behaving and if there's any sort of packet loss on the network. A traceroute is used to determine if one IP address can reach another IP address, and usually it will show how many hops it takes to get to the other IP address, and also what some of the IP addresses are in between hop A and hop B. And here where things start to get even more fun, where we have the layer 4 transport layer, which is the TCP and UDP ports that are used for different sorts of connections over the network. One of the main differences between TCP and UDP is that TCP connections or ports, whenever they're communicating, they'll perform error checking and resubmit the data to send it over the network again to ensure that all of the information gets there. Whereas a UDP connection, for instance, if we were on the phone and having a conversation, and if I said something, the phone would not retransmit what I'm saying. If I was streaming a video on Netflix, it would not resubmit that information. I would have to go back and rewind and have it send the information that way. But that's one of the biggest differences. And a lot of times, and especially nowadays with moving to a remote workforce and everyone connecting over VPNs to get to their company network, those sort of connections are TCP related, and that has to do a lot with the security and the state of the connection itself, just because TCP is a lot more trustworthy than UDP. There are some protocols that use TCP and UDP ports at the same time whenever it is communicating. And for both TCP and UDP, there are 65,535 different ports that are used on computers. Not all these ports are always in use. Some of them are tied to services that are strictly disabled unless you or an administrator go through and enable those services. Depending on what sort of protocol is being used or what sort of traffic is being sent over the network, this sort of connection, TCP and UDP connections, can sort of be modified to where certain flows take precedence over other types of flows. For instance, if Janet is trying to upload a 1 gigabyte file that is nothing but text documents at the same time that the CEO is trying to have a video conference with stakeholders, you would want that video conference data to take precedence over Janet's upload. Janet's upload can go very slowly and be done throughout the day until it is complete, whereas, business critical meetings or even a phone call would definitely want to take priority over other things that are happening on the network. Layer 5 is the session layer, and this is the layer where what is known as handshakes occur. And so whenever 2 devices or multiple devices are in agreement as to what sort of communication protocol is being utilized, they'll perform what is known as a handshake. And once that handshake is confirmed and established, that's when connections can go ahead and start passing data. They'll maintain the connection, and then also once the connection is over and done with, this is the layer that terminates the connection gracefully so that a session can be reestablished, or if the connection is lost, you can go back and try to reestablish that connection automatically. One of the most important layers in today's world is layer 6, the presentation layer. And I say this because this is where encryption and decryption takes place on all sorts of data. Whether you're connecting to your company's VPN, or if you're performing a digital signature on a document that you receive from your boss, this is the layer where the stuff on the back end that encapsulates and decapsulates data takes place. This can have a lot of overhead and cause a lot of additional resources to start being utilized, such as high CPU and high memory. Also at layer 6, we have another type of handshake that's called a SYN-ACK handshake. And so what this does between a client and a server is that the client will actually send out a request in which the server will respond with, and they will begin to establish that handshake connection and determine what sort of communication protocol they are using. And of course, these protocols need to be the same on whichever they agree with. It is also important to note that the syntaxes that are used with the different communication protocols are formatted at this layer. And so what that means is that whatever sort of coding or programming language is being used on the server side, the client needs to be able to also read those syntaxes as well. And so this layer, the presentation layer, sort of plays the middleman, or maybe a translator is a better way to say it as well. But this is the layer that ensures that both parties are able to understand one another. And of course, we have the last layer, which is layer 7, the application layer. This is the actual layer where myself and end users, of course, engage with whatever content is being displayed on the laptop or on the tablet. This is where you would type in your password. This is where you would go to a website. This is where you would do any sort of interaction with the computer interface itself. Part of the reason that I wanted to talk about the OSI model today is because it is everyone's job and role to ensure that all layers are as secure as possible. And what I mean by this is that if there was a hacker or maybe a disgruntled employee who was able to get physical access to layer 1, there's a possibility that they would be able to escalate their privileges or launch an attack that would give them escalated privileges throughout the OSI model. And that way they would be able to gain access to things that they wouldn't normally have access to. I know that this was not a full breakdown of every layer in the OSI model, but I hope that some people were able to take away a little bit of information about some of these and hopefully get a better visualization of what is happening at some of these layers. I think that it's important to understand the OSI model from a professional perspective, whether you're looking to be certified or not, but it gives you a better understanding of what is sort of happening in the background. And so whenever you're having issues or your neighbor's having issues, you're able to kind of find out where the first jumping off point is for your investigation. And what I like to tell people is that you get to play the role of a detective and try to determine what the issue is and ultimately solve the case.